Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 8, still on electric circuit. It says 3 resistors and an electric device rated 16 watts are connected to a battery of EMF 36 volt and an unknown internal resistance R as shown in the circuit diagram below. Ammeter A2 reads 2 amperes when switch S is closed. So we see the switch S there. Then 8.1 says define the term EMF of a battery in words. So let's quickly run to that. We say EMF is the maximum energy provided by the battery per coulomb of charge passing through it. Right. Okay, then 8.2 says calculate the resistance of the electrical device. And then it's only for 3 marks. So we know a 3-mark question. It's basically something that we can just see from here. So the first thing that we want to do, let's identify our positive terminal and negative terminal in order so that we can know the direction of current. So the longer one is always the positive and the shorter one, the negative terminal, right? So that means your current now will be flowing in this direction. Then immediately at this point, there is a splitting of current, which indicates that we are now entering the parallel branch. So some of the current will split and flow to the 10 ohm resistor, and then some of the current will split and flow through the ammeter here, and then into the 8 ohm resistor, and then also to the device. Guys, I get a lot of questions when I do this. I want you to understand this, guys. The components that are within the same color here, indicated by the same color of current, that means they have the same current. The current is the same throughout those ones, because as you can see, they are connected in series. They are within the same pathway, right? So basically that's what I want to show you when I just draw this indicating different colors. So that means that the 2 amperes here is the same 2 amperes in the 8 ohm resistor, and it is the same 2 amperes in the 16 watts device, right? So that's what I mean by that. And then when it gets to that point, note that the current rejoins, and then now the total current that was flowing from the battery is now flowing to this 2 ohm resistor here. Now, because the 2 ohm resistor is connected in series alone here, that means it receives the total current, right? As we can see now, it is indicated in black, right? And the current in black was the full current that came from the battery, right? Okay, so this is how all of this operates, right? So this is how all of this operates. Now, to calculate the resistance of the electrical device, we are only looking at the electrical device, so 16 watts, right? So we are given the power. It should be simple to just say power is equals to the current squared multiplied by R. So this is a formula from the back of your formula sheet. So we are using this formula particularly because, as we can see here, we are given the current and then we know the power and we are looking for the resistance. It's pretty easy to just choose the formula, right? Then 16, and then your current is 2 square and then R. Then this is 16 is equals to 4R. If we divide by 4 both sides, then the resistance of the device is 4 ohms, right? So now we have 4 ohms here. Okay, cool. Then 8.2.2 says calculate the current passing through the battery, right? And that is for 5 marks. So note, it's a 5-mark question, meaning that we might have to calculate a missing variable somewhere before we get to calculating the current, right? So, okay, let's understand this. We are trying to calculate the current passing through the battery. For a 5-mark question, we said these are questions that normally involve 2 unknown variables. So I've been saying this for quite a while now. So this involves you having 2 unknown variables. Now, what can we do in order to calculate the current of the battery? We only know the current of the 8 ohm and the and the device here, which is 2 amperes, right? So it's 2 amperes throughout here. That means in order for us to calculate the total current, what we can use is the fact that if we calculate the current through the parallel resistors, this will be the same current that flows throughout the circuit, total current, right? So this here is the parallel branch. As we can see, there's a splitting of the current, meaning that what we do with these questions is, number one, note that we need to first combine these resistors that are in series within a parallel branch, right? So we can see that this device and the 8 ohm resistor are in series, but they're within a parallel branch. So what do? We combine them, and then it's the 4 ohm and the 8 ohm, which will give us 12 ohm. Right. Now, for a similar question like this, you can check my video on electric circuits episode number 4. So I did a similar question whereby I was specifying the fact that whenever you have resistors like this, you just combine them to form one big resist. Now, why are we doing that? We are simply counting on the fact that we know that resistors in parallel will have the same voltage, right? So what we know is that the voltage through the 10 ohm resistor will be the same voltage through the 12 ohm resistor there, right? So basically we are combining them because we know if we take the voltage of this plus the voltage of that, it has to be equal to the voltage of the 10 ohm resistor alone. So to better calculate it, or to make things simple, we just simply combine them to form that one big resistor, so that when we calculate the voltage here, we know indefinitely that it is going to be equal to that 10 ohm resistor there. Okay, so now to further calculate, we'll say we have 2 amperes. Remember, even if you were to combine these 2 resistors here, because they are in series, the current remains the same throughout. So the current would still remain 2 amperes. So now let's calculate the voltage of the 12 ohm resistor by saying current multiplied by the resistance of the 12 ohm. So the current still 2 amperes, and then the resistance is 12. Now 2 times 12 is 24 volts, right? But then what do we know? If this is 24 volts, then also the 10 ohm resistor has 24 volts, right? Because these resistors are in parallel. Note, right? Now, in order to further calculate now, we have 24 volts here. Remember, we are looking for the total current, but then we can easily calculate now the current through the 10 ohm resistor. So we say current of the 10 ohm resistor is equals to voltage over resistance. Then this will give us 24 divided by 10, right? Which is 2.4 amperes. Now, we know that the current of the 12 ohm resistor now plus the current of the 10 ohm resistor will have to give us the total current of the parallel resistors, right? So if we say 2.2, only 2, because of the 12 ohm, it's 2 amperes. As we can see here, if we can say 2 plus 2.4, this will give us 4.4 amperes. But what is it that we have discovered? The total current through the parallel resistors is also equal to the current that flows throughout the circuit. So in other words, since we know that IP is equals to I total, that means the total current that flows throughout the circuit has to be 4.4 amperes as well. Right. So that's how you calculate that. Once you know those facts, then it becomes easier to just come up with that deduction. Right. So, okay. We have now calculated the current passing through the battery, which is our total current. Now let's go to 8.2.3. We want to now calculate the internal resistance R of the battery, and to say. So again, it's 6 marks, which is probably we need we have 2 unknown variables, right? And then we would need to use the formula. Obviously, the only way we can find the smaller letter R is in this formula, the EMF formula. But then if we check here, the EMF it's given, it's 36 volts. Remember, we said you only get to use the EMF on this formula, not in any other formula. Then current here, we have calculated it in the previous question. We got 4.4 amperes, right? And then the R external, we don't have the R external. We still need to calculate the R external, but then we are looking for R internal. So again, two unknown variables. So first, let's calculate the R external. We know that R external is made out of the R parallel plus the R series, right? Now, the one in series is this one, and then the ones in parallel are this. But then what do? Immediately, we just combine these two resistors to form one big resistor, meaning the 4 ohm and the 8 ohm to form 12 ohm. That means now we can calculate the resistors in parallel like this. We say R1 multiplied by R2 over R1 plus R2. So I need you to understand that they really like this type of questions in your exam. So once you get to understand this type of questions, whereby you have series resistors in a parallel branch, then you are truly gone, right? Then 5.45 ohms. That's your resistors in parallel. Now to calculate the R external, obviously its R external is equals to R parallel 5.45. Then the only one connected in series is the 2 ohm there. So we have 7.45 ohms. Now at this point, we can now apply our EMF formula in order to calculate. So let me just erase here and then just calculate here. Okay, so to calculate EMF, there we go there, we'll say to calculate the internal resistance, meant to say. So our EMF is 36, our current, always the total current, 4.4, and then our R external, 7.45, and then R internal. Now, remember, to be more efficient with your maths, just divide by 4.4 both sides, and then 36 divided by 4.4, that gives us 8.18. I'm just going to round off to 2 decimal places. Then 7.45 plus R. Now to calculate your R is just 8.18 minus 7.45. Now it's not necessary for you to do all that. At this point, you can just calculate R and then write your solution. 0.73 ohms. So bam, that's your 6 marks, right? So that's how you go about it. So if you can always keep that in mind, once it's a 5-mark question or more, then you have 2 unknown variables, right? So you still need to first solve something before you can get to what you're actually being asked to calculate, right? Okay, now let's proceed to 8.3. 8.3, we know that's a conceptual question. So you can, from all these questions that we've been doing, we are now on episode number 8. You can see from all these questions that we've been doing, the trend has been the same. The structure of the questions has always been the same. If you can just follow through with all those episodes and make sure that you never skip any episodes, you watch them all the way till the end, then you should be able to understand any electric circuit question. Right. Okay, so 8.3 says the switch S is now opened. How will this affect the reading on ammeter A1? Right. So now they're opening the switch here. So remember, opening the switch means the current will not flow in that part, right, of the circuit. So this is our current flowing, but then because the switch is opened here, remember there will be no continuation of the current. So that means this part here is effectively cut off from the circuit because it will not be receiving any current. So that means your current can only just flow in this direction here. But then what do we see now? Only one pathway for current to flow, which means that it is now connected in series. Now, obviously, we only had the 2 ohm resistor in series, but then now we are adding another resistor in series, right? So adding a resistor in series increases the total resistance of the circuit, right? So that's point number 1. We know that if we are now about to add this, our R external would obviously be 2 plus 10, and then now will be 12 ohm. If you had to compare with the R external that we found previously, we had R external was 7.45 ohm. Now, obviously, the observation is that now the R external has increased, and then obviously, even the R total will increase, right? Then Now that we know that the resistance increases, then what will happen to the current? Remember, when they're asking about the ammeter reading, this is the current because the ammeter measures the current. Now, if the resistance increases, then we know that because resistance and current are inversely proportional, then current has to decrease. So what is our solution here? It has to say decrease. And our explanation is just what we spoke about here. So let's put it in point form, or just give the answer to that one. How would they expect you to write it? Then you say decrease, the total resistance increases, and thus current increases. Done. It's only 2 marks, so a mark for that and a mark for this. So that's how you were supposed to tackle these questions, all for a total of 18 marks. So it was a pretty giveaway question. We're just giving away marks here. So if you understand all the concepts and then you are down with the notes that I've given you, then shouldn't be a problem to you. So, okay, with all that being said, please press the thumbs up button if you've enjoyed the lesson and then have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.